Hey, welcome to the podcast.
Thanks for having me, man.
So, I was reading through this huge guide on computing, right? And there's just so much stuff. Can we start with programming paradigms? What's the difference between declarative and imperative?
Yeah, okay, so declarative is basically you just say what you want and the computer figures out how to do it. Imperative is like you spell out every single step the computer needs to take.
Okay, so then object-oriented programming is just imperative but with classes?
Kind of, yeah, it's like imperative on steroids. You define classes as blueprints, and then objects are individual things with data, properties, and actions they can do, methods.
Oh, right. And you create instances of those objects and use dot notation to access stuff, like the rubber duck example everyone uses.
Dude, yes. So the rubber duck subclass might quack differently than a regular duck, right? That's polymorphism. Same function call, totally different behavior.
That's actually sick. Okay, can we talk about algorithms like recursion and binary search and big O notation?
Sure. So recursion is when you break a problem into smaller versions of itself, but you gotta have a base case or you'll just keep going forever and crash the stack.
Wait, Stack Overflow like the website or like actual...
Both. The website's named after the actual thing. Your call stack runs out of memory because all these recursive calls keep piling up. That's where memoization comes in. You cache the results so you don't recompute the same thing over and over again.
Right, and binary search is like divide and conquer. You check the middle, pick which half to look in, repeat, way faster than just checking everything.
Exactly. And big O is how we measure that growth, like O of n for scanning an array. But factorial grows insanely faster than linear. It's about patterns as your input gets huge.
Interrupting. Speaking of arrays, there's a whole section on data structures. Arrays, linked lists, stacks, queues, hash maps. What's the deal with each one?
Okay, so arrays are contiguous memory, so indexing is lightning fast if you know where to start, but the size is fixed. Linked lists are nodes with pointers, so they're flexible, but accessing random stuff is slow.
And stacks and queues are just different ways of accessing data. Last in, first out, and hash maps use a hash function to map keys to spots, but you can get collisions.
Right. You can chain collisions, like store a linked list at that spot. Hash maps are amazing because lookups are basically instant, and they're built on top of arrays underneath.
And then graphs and trees, breadth first search, depth first search, binary search trees where everything left is smaller and right is bigger. It all connects, you know?
Totally. Trees model hierarchies like your file system. Graphs model any relationship with edges and weights for distance or cost. And which search you use depends on what you're trying to do.
Okay, now the low-level stuff. Bits, bytes, CPU cycles. 1 bit is basically a switch. 8 bits make a byte, which is 256 different combinations, and they had this example adding up to 69 that just stuck with me.
Yep. Transistors are switches. Bits are 0 or 1. 8 bits is a byte. 256 combos. The CPU fetches, decodes, executes, stores. That's the cycle.
And modern CPUs do billions of these per second, all coordinated by a clock in gigahertz. Plus, you got multiple cores and threads running in parallel.
True, but speed isn't everything. Memory's huge. RAM is where the CPU grabs data and instructions, and the heap versus stacked miners for how you allocate stuff.
Guy talked about pointers and segmentation faults and memory leaks and how languages like Python handle that automatically with garbage collection.
Right. In C, you manually manage memory with pointers that hold addresses, and you can do arithmetic with them. Mess that up, you get crashes or leaks. Garbage collection just handles it for you in higher level languages.
Okay, network stuff. The guide mentioned 404-page net found and HTTP methods like get, post, put, delete, and APIs use those to talk to databases.
Yep. The internet is the physical infrastructure. IP addresses identify machines. TCP breaks messages into packets, and the web is built on top using HTTP and URLs, with DNS translating names to addresses.
And databases, relational ones, use tables, primary keys, foreign keys, and joins let you combine data like finding book titles and authors together.
Exactly, but here's the scary part, SQL injection. The guide literally shows how an attacker can craft input so that as long as this username exists in the database, access is granted. You have to clean your inputs.
It's so simple and so dangerous. Okay, last thing, machine learning. You can't just code what a bee looks like, so you teach an algorithm with tons of data instead.
Right. You split your data into training and test sets. Pick a model like a neural network that adjusts weights, train it on examples, then check accuracy on test data and keep improving.
And if someone actually wants to play with this stuff, the guide recommended Brilliant, Interactive lessons that make it all click.
For sure, seeing it in action is how you actually remember it. Building little projects ties all the theory together.
Man, that was dense, but so good. We covered paradigms, data structures, hardware, networking, security, machine learning.
Basically everything except building a CPU from scratch. Chuckling. But the cool part is the core ideas repeat. Data, algorithms, and layers connecting hardware to what users see.
I'm definitely saving this, especially that SQL injection part. And the rubber duck thing just makes everything better.
The rubber duck debugging is eternal. All right, one last thing. Think in layers, clean your inputs, and measure before you optimize.
Perfect. Thanks for walking through all that. Next time, can we deep dive into neural networks? Like, I'm already pumped.
Absolutely. Bring coffee and a whiteboard. We'll draw backpropagation and activation functions and make it fun.
Listen, deal. See you next time.
Later, and remember, sanitize your SQL and don't overclock without thermal paste.